Hello everyone, hello students. So I'm Brijesh Kumar and today we are going to start our day 17 from our JEE 45 days crash course. Okay, so let's begin with this and let's enjoy this class. So in this class, what we are going to study, we are going to learn redox reaction. That's an important part for JEE exam. Okay, so let's begin. You can see the weightage. So the weightage for this particular chapter for this particular JEE exam is this 1 to 2 questions, and this is based on previous year exam analysis. So let's begin with the session. So today we are going to learn first of all electronic concepts of oxidation and reduction. This concept you already learn a little bit about this oxidation and reduction in your lower grades. Okay, this is going to be very interesting. So oxidation, the word itself suggesting that oxidation means addition of oxygen and reduction means addition of hydrogen. So oxidation means addition of oxygen but removal of hydrogen, and reduction means addition of hydrogen but removal of oxygen. That's going to be very interesting. So you can see some definitions of oxidations, like the process in which an atom or ion or molecule loses electrons. Suppose I am taking Mg. So Mg gives Mg2 positive plus 2 electron. That means in this reaction Mg is undergoing oxidation process. Okay, suppose I am saying Mg plus O2, or we can say a balanced equation, Mg plus O2 gives 2MgO. So in this process addition of oxygen is taking place, so this is also oxidation, like this. Also you can understand, like Mg is 0 here. What I am saying 0 and this plus 2, I will you will get a clear idea about this in the upcoming time. Okay, so you can see addition of oxygen electronegative element to a substance. Addition of oxygen is also known as oxidation, and addition of any electronegative element to a substance is called what? Is called oxidation. Removal of hydrogen, I already told to you. Removal of hydrogen or removal of electropositive element from a substance is called oxidation. Okay, so these are some definitions of oxidation. Let's go to the definitions of reduction. You can see reduction, I already told to you, reduction is like addition of hydrogen. Addition of what? Hydrogen. Addition of hydrogen or removal of oxygen. So the process in which an atom, ion or molecule gains electron. Suppose I am writing Cl and plus electron and product will be Cl negative. So Cl is what? Cl is reduced here because of gain of electron. Because of gain of electron. Okay. And the second type of definitions, you can say removal of oxygen. I already told to you, addition of hydrogen or removal of electronegative element. Removal of electronegative element from a substance is called reduction. Addition of hydrogen or addition of electropositive element, addition of an electropositive element to a substance is called what? Reduction. Oxidation and reduction always occur together, then the reaction is called redox reaction. So in redox reaction, the reactions in which oxidation and reductions are occurring simultaneously are called redox reaction. So let's begin with the definitions of redox reaction. You can see redox reactions involve the transfer of electrons from one species to another species, because you know that during oxidation loss of electrons will take place and during reduction gain of electron will take place. If one species is losing electrons and another is gaining electrons, so what happens? Definitely, if loss of electron and gain of electron taking place in a particular reaction, right, simultaneously, then that particular reaction is called redox reaction, right? So oxidation and reduction occur simultaneously, and you can see there are two words, two specific terms, reducing agent and oxidizing agents. Okay, what is reducing agent? Reducing agent is that agent or that species that undergoes oxidation. So reducing agent oxidize itself and reduce others. That's the point here. Reducing agents oxidize itself and reduce others. So the species that undergoes oxidation and causes the reduction of another species or acceptor of electrons, you can say, that is reducing agent, acceptor of electrons, right? Okay, next you can say oxidizing agent, the species that undergoes reduction and causes the oxidation of another species, causes the oxidation of another species, right? So that is called what? Oxidizing agent, causes the oxidation of another and itself reduced, that is called oxidizing agent. So there are four terms: reduction, oxidation, reducing agent and oxidizing agents. Okay, let's move to the next one. The important part is oxidation number. First of all, let's learn how to find oxidation number, right? How to find oxidation number. So you can see here oxidation number, uh, like oxidation state. Okay, oxidation number and oxidation state are little bit different. You can see oxidation number is a concept used to track the electron flow in a redox reaction. Redox word itself suggesting that red plus ox. Red plus ox means red means reduction and ox means oxidation. That means the reactions in which the oxidations and reductions are occurring simultaneously are called redox reaction. Okay, let's go back to the oxidation number. It represents the charge on an atom would have if the electrons were transferred completely. Rules for assigning oxidation number. What are the rules for assigning oxidation number, right? You can see the oxidation number of an element in its elemental form is 0. For example, I am saying only H, so it is 0. For example, I am saying H2, it is 0. Okay, for H2 it is 0. For example, Cl2 it is 0, right? Cl2 it is 0. For example, I am saying sodium, okay, only sodium, so it is 0, like this. The oxidation number of a monoatomic ion, suppose the monoatomic ion is here, like H positive, like Cl negative, like F negative, like Na positive, like O2 negative. So the oxidation number is equal to its charge. So oxidation number of H positive is +1, oxidation number of Cl minus is -1. So oxidation number can be positive or can be negative, okay, and also can be 0. Okay, so for this -1 +1 -2, that's going to be very interesting. Next point, the sum of oxidation number in a neutral compound is 0. For example, you are taking H2SO4, right? You are taking H2SO4. Suppose you have to calculate the oxidation number of sulfur. So let's suppose the oxidation number of sulfur is X, okay, and the oxidation number of hydrogen is +1, and the oxidation number of O2 negative is 2 negative, right? What is that? 2 negative. So let's put these values. So there are 2 hydrogens, so 2 into 1, so 2, then 1 sulfur, so only X, and there are 4 oxygen, yeah, you can say 4 oxide, okay, so -8 will be equal to 0 because this is neutral. Okay, so the sum of oxidation number will be equal to 0. Now you can calculate the oxidation number will be what? -2 and +2, -8 and +2, it will be -6, and you will get the answer will be +6. So oxidation number of sulfur in H2SO4 is +6. Okay, like this you can calculate the oxidation number. So the sum of oxidation number in a neutral compound is 0. Let's go to the rule number 4. Rule number 4 is saying that the sum of oxidation number in a polyatomic ion is equal to its charge. Suppose I am writing CO3 2 negative. CO3 2 negative. Suppose I am writing HNO3, right? So this is a polyatomic, but it's not an ion. Okay, it's not an ion. So let's write HSO4 negative. So you have to find again the oxidation number of sulfur. So the oxidation number of hydrogen is, I already told you, is +1, H positive ion, and for oxygen 2 negative is -2. Let's put the values. Suppose this is X, so hydrogen is only 1 here, so 1 plus X and -2 for the 8, so -8 equal to its charge. Equal to its charge is -1. If it will be +1, so you have to put +1 here. Okay, whatever is the sign and whatever is the charge present here, you have to put the exact value with sign. Okay, so you can see here X will be -8 minus -8 and +1 will be -7, and -7 will go to the right hand side, then you will get +6 will be the answer again. Okay, so the oxidation number of sulfur in HSO4 negative is also +6. Very simple. In most compounds the oxidation number of oxygen is -2. Let's that's we are using, right, in H2SO4, in HSO4 negative, and hydrogen is +1. Yes, definitely. Fluorine always has an oxidation number of -1. Fluorine always has an oxidation number of -1. Now let's understand some types of redox reaction. Okay, you are getting a clear idea about the types of redox reaction in few minutes. So the first reaction is combination reactions. You already learned these types in your you can say lower grades. Okay, so combination reaction may be denoted in this manner, like A plus B gives, see, very simple, when 2 or more reactants combine, right, to give a single product like Mg plus O2. I already told to you. Another example you can take like H2O plus O2 gives H2. I'm not writing the balanced equation. If you want to write the balanced equation, you can write like 2H2 plus O2 gives 2H2. That's very simple thing, right? Okay, what is the opposite of this combination reaction? Definitely decomposition reaction. So decomposition reaction, in this reaction, this is the opposite of combination reactions, and a single reactant is here and break down into multiple products. Break down into multiple products like A gives B plus C. Okay, like A gives B plus 3. Like decomposition of lead nitrate, you can take some examples. Next is displacement reaction. Displacement reaction is very simple. The word is saying displacement. That means in this displacement reaction or in this reaction, an ion or an atom in a compound is replaced by an ion or an atom of another element. It may be denoted as like X plus YZ gives XZ plus Y. This is like a single displacement reaction. Okay, so you can see here X is more reactive here. X is more reactive here than what? Than Y. That's why X is able to move or displace this Y from this YZ compound. Okay, so X plus YZ gives XZ plus Y. This is called displacement reaction, or simply you can say single displacement reaction. Displacement reactions are further of two types. You can say the metal displacement reactions or non-metal displacement reaction. You can see the reaction zinc plus copper sulfate, right? So copper sulfate plus zinc, that means you can see zinc is more reactive than copper. So zinc can displace the copper from its salt solution, which is copper sulfate solution. So a metal in a compound can be displaced by another metal in the uncombined state. So zinc is more reactive than copper. That's why zinc is able to do this. Okay, and it will form product copper solid plus ZnSO4 aqueous. Copper solid plus ZnSO4 aqueous. So zinc can displace copper from its copper sulfate solution, and you will get zinc sulfate plus copper solid as a product. So this is the single displacement reaction example. What is that? This is the single displacement reaction example. Okay, again I am writing zinc is more reactive. Zinc is more reactive than what? Zinc is more reactive than copper. Zinc is more reactive than copper according to the reactivity series. Okay, you can take more reactive. Okay, let's go to the next type. Displacement reaction. The next type is non-metal displacement reaction. In non-metal displacement reaction, the non-metal, okay, displacement redox reactions include hydrogen displacement, and rarely occurring reaction involve oxygen displacement. Okay, like you can say 2Na sodium reacting with water, that means 2H2O, you will get sodium hydroxide, right? When you will mix this, when you will do a reaction of sodium with water, you will get sodium hydroxide, and hydrogen gas is releasing here. Hydrogen gas is releasing here because sodium is highly reactive. You can say sodium is highly reactive metal, and the reaction will be exothermic as well. Highly reactive metal. So when it will react with water, it will release hydrogen gas. Okay, and you can see along with sodium hydroxide. So the reaction will be 2Na plus 2H2 gives 2NaOH aqueous plus H2 gas. So this is the non-metal displacement reaction. What is happening here? Sodium is displacing the hydrogen. Sodium is, you can write like water like this, right? So sodium is displacing this hydrogen and it is forming NaOH. Okay, NaOH plus H2 gas is released here. Okay, that's a concept here, you can understand easily. So this is a non-metal displacement reaction. Let's go to the disproportionation reaction. That's important. Okay, I think you might heard this word in your lower grades, but this is a new definition. Okay, so you can see this is a new definition. I think you didn't learn this type of definitions in your lower grade, like disproportionation reaction. So let's understand what is this disproportionation reaction. This is very simple. In a disproportionation reaction, disproportionation word simple meaning you can understand self oxidation and self reduction. The simple meaning or simple way is self reduction and self oxidation. Self reduction and self oxidation. So in a disproportionation reaction of an element in one oxidation state is simultaneously oxidized and reduced, right? That means simultaneously the species is undergo oxidation as well as reduction. So the decomposition of hydrogen peroxide, you can say this is a hydrogen peroxide, H2O2 is the formula. Is a familiar example of this reaction. You can say oxygen experience disproportionation. Okay, so what is the oxidation state, oxidation number of, you can write the reaction here. What is the oxidation number of oxygen here? 2H2O2 gives 2H2O plus O2, right? 2H2O2. Oh, I'm not writing the states, you can write the states here. Okay, aqueous, liquid and gas. Okay, 2H2O2 gives 2H2O plus O2. So O2 is in what, in its elemental form, like molecular form. Okay, and so it is 0. Okay, now you can see 2H2O2. 2H2O, so hydrogen is plus 1. So let's assume for oxygen it is X. So what is happening here, it will be 2 because 2 hydrogen. Then oxygen is number of oxygen atoms are 2 here, so it will be 2x, and it is neutral, so 0. So 2x will be minus 2 and x will be minus 1, right? So the oxidation number of oxygen is minus 1 here, and here again you can calculate 2 not 2x, it's only 2, and for oxygen it is x, but there is only, here is only one oxygen atom. Okay, and it is neutral, so it will be 0, so x will be minus 2. So what you can observe here, minus 1 to minus 2, oxidation number is decreasing. I want to tell you one more definition, oxidation or reduction. In oxidation, oxidation number will increase, and in reduction oxidation number will decrease. So in terms of oxidation number, you can check the oxidation number. If the oxidation number is increasing from reactant to product, then you can say what, it will be oxidation. And if oxidation number will decrease, so you can say it will be reduction. Okay, so you can say minus 1 to minus 2, definitely it is undergo or reduction, right, because it is decreasing, so it is a reduction. And minus 1 to 0, what is this, minus 1 to 0, definitely it is increasing, so it is undergo oxidation, it is undergoing oxidation. So you can say H2O2 is oxidizing as well as H2O undergo oxidation as well as reduction, right? From H2O2, the oxygen undergo oxidation as well as reduction, you can say like this as well. Okay, so this is the example, that's a very familiar example. So oxygen experience disproportionation reaction, that means self oxidation, itself oxidized and itself reduced. That's the point here. I hope you are getting this point. This is the disproportionation reaction. Okay, let's go to the balancing of redox reaction. That's an important part. So how can we balance any redox reaction? There are like two methods we are discussing today. So you can see first is oxidation number methods and second one is ion-electron method. So here are some steps. So first of all, let's understand the steps of how to balance a redox reaction, right? With the help of oxidation number method, then we will be discussing the ion-electron method. So first of all, the step 1 is here in case of oxidation number method. The first step is assigning oxidation number, right? Assigning oxidation number will be the first step in both cases, in ion-electron method as well as in oxidation number method. So assign oxidation number to all the elements, whatever the elements are present in a particular reaction in reactant side or product side, assign oxidation number to all the elements in the reactants and product side. Then the oxidation number is a positive or negative number that represents the charge an atom would have if the electrons in the bonding were completely transferred, like this. Okay, step 2, identifying the reducing and oxidizing agents, or simply you can say identify which species is undergoing oxidation and which species is undergoing reduction. One thing I want to tell you, if you will find that, suppose I am saying like A plus BC gives AC plus D, like this. Suppose I am saying A will undergo oxidation. That means if A is undergoing oxidation, and you know very well reducing agents reduced others and oxidize itself, that means A will act as a reducing agent. So the species that is undergoing that is oxidized or that is undergoing oxidation is known as reducing agent, and the species that is undergoing reduction is known as oxidizing agents. Okay, so these are some opposite terms, don't get confused. Okay, reducing and oxidizing agents. The reducing agent is a species that undergoes oxidation. Told you, I already told you can say reducing agent as that species which reduce others and oxidize itself. That means it will lose electrons itself, right? So it will undergo oxidation. The oxidizing agent is that species that undergoes reduction, that means gains electrons, right? That undergoes reduction itself and oxidize others. Next step will be balancing redox half reaction. Okay, make two half. Okay, that first will be the oxidation part and the second will be the reduction part, and write separate half reactions for the oxidation and reduction process, and then balance the atoms in each half reaction except hydrogen and oxygen. Okay, because we will first balance the other atoms, then we will go to the hydrogen and oxygen balancing part. Balance redox half reactions. Then after balancing the other atoms, balance oxygen atoms by adding water molecules H2O and balance hydrogen atom by hydrogen ions if it is a acidic medium. If it is a acidic medium, if it will be a basic medium, then use OH negative ion. Okay, then use OH negative ion. Okay, in basic medium, in acidic medium, you have to use H positive ion. In basic medium, you have to use OH negative ion. Okay, balance the charge by adding electrons. Balancing the overall equation, multiply the half reactions by appropriate coefficient so that the number of electrons transferred is the same in both half reactions, and add the half reactions together and cancel the common terms. For example, let's balance the following redox reaction with the help of this method, that is oxidation number method. What is that? Oxidation number method. The reaction is Cu plus HNO3, that means copper is reacting with nitric acid, that is HNO3, that is a strong oxidizing agent, and you will get copper nitrate CuNO3 whole twice plus NO nitric oxide, or you can say nitrogen monoxide plus H2. So let's start the steps and then we have to do this. So first of all, assign the oxidation number. That's the step. So let's assign the oxidation number. It is in elemental form, so 0. Hydrogen, it will be +1, oxygen will be -2. For nitrogen you can calculate, it will be 1, then plus x, then -2, 3 just 6, and it is neutral, so 0, so x comes out to be +5, x comes out to be +5. Okay, similarly you can calculate for this copper, and NO3 negative, you know very well, so copper is +2 here. Okay, no need to calculate for this nitrogen and oxygen. If you want to calculate, you can calculate. Okay, and then for this nitrogen you can say it will be what? +2. Okay, and it will be -2, and here for hydrogen is +1, and here for oxygen is -2. Like this you can calculate simple. So you can say hydrogen and oxygen, they are same oxidation, they are in the same oxidation state in the reactant side and in the product side. That means +1 for hydrogen and -2 for oxygen. Okay, but for nitrogen you can see nitrogen is undergoing +5 to +2, +5 to +2. That means decrease in oxidation number means reduction, and copper is undergoing oxidation. So this is an example of redox reaction. Yes, this is an example of redox reaction. Suppose in a particular reaction, if you are not able to find the reduction and oxidation simultaneously, so you cannot say that it will be a redox reaction like this. Okay, so you have to be very clear while finding the oxidation numbers. Okay, let's go to the step 1, assigning oxidation numbers. So I already assigned copper 0, hydrogen +1, nitrogen +5, and oxygen -2 we have assigned. Okay, in the reactant side and product side we have assigned. Then identify oxidized and reduced elements. So we already find it, right? We already found it. You can see copper is getting oxidized here and nitrogen is getting reduced here. So you can see copper is oxidized, loses electrons, Cu 0 to +2, and nitrogen is reduced here +5 to +2. Okay, +5 to +2, so change of -3 charge here, change of -3. Okay, change of -3 charge here. Let's go to the next part. You can see copper 0 to +2, nitrogen is going +5 to +2, and change of -3 charge here, change of -3 charge here, and oxygen -2, that means no changes here, right? Okay, let's balance the number of atoms. So you can see in that particular reaction, copper 1 on both side. Okay, hydrogen in the reactant side, this is for reactant side, this is for product side. Okay, hydrogen 1 on reactant side but 2 on product side. Okay, nitrogen you can count, if you want to count, you can see nitrogen 2 here, 2 + 1 3 here, and the reactant side only 1, in the reactant side only 1. So you can say nitrogen will be what? 1, and 2 + 1 3. Okay, and oxygen will be, oxygen you can count here. Again oxygen will be 3 here, and here 3 to just 6, +1 7, +1 8. Okay, so 8 will be the oxygen. So 8 oxygen will be there, 8 oxygen. Okay, let's go to the next. Balance electrons. Copper loses 2 electrons and nitrogen gains how many? Nitrogen gains plus nitrogen is going +5 to +5 to what? +2. Okay, +5 to +2. So nitrogen is gaining 3 electrons. Nitrogen is gaining 3 electrons. Okay, let's go to the next part. Copper loses 2 positive charge and nitrogen gains 3 positive charges. Nitrogen gains 3 positive charge. Okay, let's equalize the charge. Then verifying balance, and after verifying the balance, you will get this balanced chemical equation. So the balanced chemical equation will be 3Cu plus 8HNO3 will give 3CuNO3 whole twice plus 2NO plus 4H2O. Let's check that this is balanced or not. So copper, hydrogen, nitrogen, and oxygen. Reactant side and product side we are checking. So copper in the reactant side you can see 3 copper, and product side 3 copper, hydrogen 8 hydrogens, okay, and product side 4 to the 8 hydrogens, okay, and reactant side you can see 8 3 ja 24 oxygen, okay, product side 3 to the 6 6 3 ja 18 18 plus 2 20 20 plus 4 24 oxygen, and nitrogen you can take 8 nitrogen, and you can take here 3 to the 6 6 plus 2 8 nitrogen. So both side 8 nitrogens are available. So you can see the number of atoms of each and every element on both side, reactant side and product side, are equal. So you can say this is a balanced chemical equation. Let's go to the next method, that is going to be again very interesting. That will be what? That will be ion electron method. So first step, I already told to you, the first step in both methods is assigning oxidation number. So what is the first method? Assigning oxidation number. So assign oxidation number to all elements, okay, in the reactants and products. The oxidation number is a positive or negative number that represent the charge. Then identify the reducing and oxidizing agents. The reducing agent is the species that undergo oxidation, that means loss of electrons, and the oxidizing agent is that species that undergoes reduction, that means gain of electrons. Then step 3, determine the change in oxidation number for each element. The change in oxidation number is equal to the difference between the oxidation number of the elements in the reactant and the product side, right? Okay, suppose Mg gives Mg2 positive plus 2 electron. So you can see Mg here in 0 oxidation number, and here it is plus 2. So it is undergoing 0 to plus 2. That means oxidation will take place because oxidation number is increasing. So what is the change in oxidation number? Let's write for change delta, and change in oxidation number is equal to the oxidation number in product is 2 and oxidation number in reactant is 0. So 2 minus 0 will be 2. So 2 is the change in the oxidation number, and if you say specifically, so it will be plus 2. If these are not equal, then multiply by suitable number so that these becomes equal. Write separate half reactions for the oxidation and reduction process. You have to write oxidation half reaction and you have to write reduction half reaction. Balance the atoms in each half reaction except for oxygen and hydrogen. Like the steps are similar for some time. Okay. Balance the atoms in each half reactions by adding the appropriate number of water molecules and hydrogen or hydroxide ion. Hydrogen ion or hydroxide ion. Okay, hydroxide means OH negative, H positive for acidic medium and OH negative for basic medium. Balance oxygen by atoms by adding water molecules. Okay, let's go to the next step. Step 5, writing half reactions. In writing half reactions, balance hydrogen atoms by adding hydrogen ions, okay, if it is a acidic medium. Finally balance the ionic charges by adding H positive and OH negative for respectively, like H positive for acidic medium and OH negative for basic medium. Okay, check out the number of atoms and the charge are balanced on both sides or not. Finally simplify the equation by removing any common factors from the coefficients. For example, you can see this reaction, okay, and we are doing this example with oxidation number method. Then the next example we will do with the ion electron method. So you can see another method to balance a chemical to balance a redox reaction, okay, with the oxidation number method. Okay, so this is the unbalanced equation. Fe plus HNO3 gives FeNO3 whole thrice plus H2O plus NO2. First of all, assign oxidation number. So you can see Fe is 0 here and Fe is plus 3 here. Okay, for nitrogen you can see it will be plus 5, because if you want to assign for nitrogen, so it will be plus 1, it will be x, it will be minus 6 equal to 0. So x will be plus 5, x will be what? Plus 5. Okay, then for hydrogen you can assign again plus 1. If I want to write here hydrogen plus 1, oxygen minus 2. For hydrogen it is plus 1, oxygen minus 2. For nitrogen it is plus 4 and oxygen minus 2. For NO2, how to assign? Definitely you have to write x here, minus 2 to the 4, minus 4 equal to 0, x will be plus 4. Easy. Okay, so you can see here the oxidation number. Okay, initial oxidation number, that means in the reactant side, this is for reactant side, reactants, and this will be for product side. This will be for product side. Okay, then identify oxidation and reduction. You can easily identify 0, 2 plus 3, it is undergoing oxidation. Fe 0 2, it is going to Fe3 plus, that means 0 to 3 plus. and HNO3. In HNO3 nitrogen is at +5 and in NO2 it is at -2. So definitely it is undergo reduction. So nitrogen is undergoing reduction. So nitrogen is undergoing reduction, so HNO3, right? So nitrogen is what? So HNO3 is acting as a reducing agent here or oxidizing agent. Because it is undergoing reduction, that means it will reduce others and oxidizing itself. Oxidizing itself, reduce others. Listen me very carefully. Reduce others and oxidizing itself, that is called reducing agents, and it is a oxidizing agent because it is reducing itself and oxidizing others. Okay, so HNO3 will be an oxidizing agent. Yes. So you can see it it undergoes reduction, so definitely it will be an oxidizing agent. If it will undergo oxidation, so it will be a reducing agent. Okay. Okay, so Fe is oxidized 0 to +3 and nitrogen is reduced from +5 to +4. You can say +5 to +4. You can see for nitrogen it is +4 and for oxygen it is -2. Okay, calculate the change in oxidation number. Change in oxidation number for Fe, you can say +3 minus 0. +3 at product side and 0 like in the reactant side. So you will get +3 is the change in oxidation number. Similarly, change in oxidation number for nitrogen it is +5 minus +4, you will get +1. Okay. Then balance electrons. Since Fe loses 3 electrons and nitrogen gain 1 electron, we need to multiply the NO2 coefficient by 3. Right, we need to multiply the NO2 coefficient by 3. So you will get Fe plus HNO3 gives FeNO3 whole thrice, right? Ferric nitrate plus H2O plus 3NO2. Balance remaining elements. So multiply the HNO3 coefficients by 3 to balance hydrogen and oxygen. So you can multiply with 3 here and you can see here hydrogen and oxygen are balanced now. Check the answer both side of the equation. Iron balanced, nitrogen balanced, nitrogen, iron, Fe, hydrogen and oxygen are balanced. That means Fe both side 1. If you will make a table, so this will be element, here are reactants and here will be the products. Okay, and this will be element. So iron and nitrogen and oxygen, and another one is what? Iron, nitrogen, hydrogen and oxygen. Okay, nitrogen. So you can count how many iron both side. You can write here Fe and Fe. So both side 1. How many nitrogen? You can see both side 3 nitrogen. How many hydrogen? Both side 9 hydrogens. How many oxygen? Both side 15. Okay, so you can count like this. Thus the final and balanced chemical equation will be Fe plus 3HNO3 gives FeNO3 whole thrice plus 3H2O plus 3NO2. Okay, this is the final balanced equation and we have done with this balancing part with the help of this oxidation number method. So let's balance the redox reaction. Let's balance another redox reaction with the example of ion-electron method. Okay, steps you know very well. Assign oxidation number. You can see the steps. Then identify the reducing and oxidizing agents. Then identify reducing the, if there is an increase in oxidation number, it will be what? It will be, if it is an increase in oxidation number, so it will be undergo oxidation. If there is a decrease in oxidation number, then it will be reduction. Okay, so like this you can, if the species is undergoing reduction, definitely it will act as oxidizing agent. If the species is undergoing oxidation, then you can say it will be a reducing agent. It will be a reducing agent. Then write half reaction. Separate the reaction into 2 half reactions, one for oxidation and one for reduction. In the oxidation half reactions, the reducing agent loses electrons and increasing in its oxidation number. In the reduction half reaction, the oxidizing agents gains electron and decreasing its oxidation number. Step 4, balance the atoms. Balance the atoms in each half reaction excluding oxygen and hydrogen. Start by balancing the atoms other than oxygen and hydrogen. That's the point here. Add water molecules to the side that has fewer oxygen atoms and balance the oxygen atoms by adding H2O molecules. Clear? Then you can see add H positive ions, that means hydrogen ions, to the side that has fewer hydrogen atoms. Okay, and balance the hydrogen atoms by adding H positive ions. So you can see the steps. Okay, balance the charges in each half reactions by adding electrons, and the number of electrons lost in the oxidation half reaction should equal the number of electrons gained in the reduction half reaction. That means you have to multiply each half reaction by a factor to equalize the number of electrons transferred. That's the point here. Okay, so multiplying half reactions is the step 8. The goal is to make the total number of electrons lost or gain equal, so that we can cancel out them when adding. Okay, so next step is add half reactions. Add the balanced half reactions together, cancel out any common species on both sides of the equation. Then you can see step 10, check for balancing. This will be the definitely common step in all the balancing part. Make sure the number of atoms and charges are balanced on both sides of the equation, right? You can see an example. Suppose I want to balance this unbalanced equation. Okay, so let's balance this unbalanced equation with the example in acidic medium also. Okay, so Fe2 positive plus MnO4 negative plus H positive gives Fe3 positive plus Mn2 positive. So we are balancing this equation in acidic medium. First step is what? Assign oxidation number. So you can see this is monoatomic ion, so plus 2 for Mn, you can assume x minus 2 4 jump minus 8 and equal to minus 1, it comes out to be plus 7. For hydrogen it will be plus 1, for Fe it will be plus 3, for Mn it will be plus 2. Okay, you can see Fe plus 2 to plus 3. Oxidation, Fe is going plus 2 to plus 3. So definitely it is oxidation. It is undergoing oxidation. Mn plus 7 to plus 2. So definitely Mn is undergoing reduction. Mn is undergoing reduction. So first step is clear. Then identify reducing and oxidizing agent. We have identified Fe2 positive is getting oxidized, so it is a reducing agent because Fe2 positive to Fe3 positive, that means it is undergoing oxidation by loss of electron. And MnO4 negative is gaining electron, right, while converting from MnO4 negative to Mn2 positive. Okay, you can see Mn2 positive. Okay, that's going to be very simple, so it will be the oxidizing agent. Next, write half reactions. So oxidation half reactions and reduction half reactions you have to write. So Fe2 positive and Fe3 positive. Fe2 positive gives Fe3 positive. This is the oxidation half reaction, or simple you can say OHR. Reduction half reaction RHR. RHR, MnO4 negative to Mn2 positive, that means plus 7 to plus 2. Okay, now what you have to do, the next step, step 4. Step 4 is balance the atoms. You can see 1 Fe already balanced. You can see 1 Mn already balanced. Balance the atoms other than hydrogen and oxygen. Other than hydrogen and oxygen we are balancing. Now let's balance the oxygen atom first. So Fe2 positive, Fe3 positive, no oxygen atoms, and this is already balanced. Reduction half reaction, there are 4 oxygen. So what you have to do, you can add water molecules. Okay, you can add water molecules to balance oxygen atoms. So you can see, because we are doing this reaction in acidic medium, so we can use only H positive, right? We can't use OH negative. Okay, so MnO4 negative gives Mn2 positive. So in the left hand side, that means the reactant side, 4 oxygen are there, so you have to make equal, right? That means you have to put 4 H2O in the right hand side, in the product side. Okay, now you can see 4 oxygen atom on the both sides, so the oxygen atoms are balanced. But if you are adding 4 H2O, so what happens now, the number of hydrogens are added here, and the number of hydrogens are or you can say no hydrogen atoms are present on the left hand side. So you have to balance, or you have to put hydrogen as well. Okay, left hand side. So you can see balance hydrogen atom will be the next step. In oxidation half reaction, no hydrogen atoms are there. Okay, but in reduction half reaction, you can say 8 hydrogen atoms are there. If there are 8 hydrogen atoms, so you can put 8 H positive ions in the left hand side, in the reactant side, to balance hydrogen atoms, so the equation becomes Fe2 positive to Fe3 positive. That's okay for oxidation half reaction. And the reduction half reaction becomes MnO4 negative plus H positive. How many H positive? You can see plus 8 H positive gives Mn2 positive plus 4H2. Now you can see the number of atoms of each and every element in oxidation half reaction and reduction half reactions are balanced, but the charge is not balanced. You can see here the charge is plus 2, total charge, and here the total charge is plus 3. So how can we balance the charge? So finally you have to balance the charge with the help of electrons, because we are doing the ion-electron method. So suppose I am adding 1 electron here. So 1 electron means 1 negative, so 3 plus 3 and 1 negative, it will be plus 2. So the charges becomes equal. Similarly, total charge will be -1 and +8, that means +7 and +2. So what you can do again, you can only decrease, you can only add negative charge, you can only add negative charge. If it is positive and you have to decrease a positive, so you can add negative, right? So you can add 5 electrons here. So the equation becomes what? Equation becomes MnO4 negative plus 8H positive plus 5 electron gives Mn2 positive plus 4H2. That's the concept. But I already told to you the number of electrons must be equal on in both reactions while adding, so that we can cancel out these. So what you have to do, balance charges, you can see Fe2 positive gives Fe3 positive, no charge change. You can see the charge change is what, we have added one electron on which side, in the product side. Okay, we have added one electron here. In reduction half reaction, you can see charge change from +7 to +2, so we have added 5 electrons here, we have added 5 electrons here. Now you can see oxidation half reactions. In oxidation half reactions, what we have to do, we have to multiply, because the equation is Fe2 positive plus electron, not here, Fe2 positive plus electron, Fe3 positive plus electron. Okay, Fe2 positive gives Fe3 positive plus electron, and this is the oxidation half reaction. And the reduction half reaction is MnO4 negative plus 5 electron gives Mn2 positive plus 4H2. Now it is clearly visible that in the oxidation half reactions the number of electrons are 1, so you can multiply the entire equation with 5 and then you can add. So what you can write, 5 Fe2 positive plus 5 or not plus 5, you have to write, gives 5 Fe3 positive plus 5 electron. Then you can see 5 electron, you need not to show, but you can cancel out. Okay, then you will get the equation 5 Fe2 positive plus MnO4 negative gives 5 Fe3 positive plus Mn2 positive plus 4H2O. Now you can see the equation 4H2O you have to write here, 4H2O. Okay, now you can see the equation 5 Fe2 positive plus 5 MnO4 plus MnO4 negative plus 8H positive gives 5 Fe3 positive plus Mn2 positive plus 4H2O. Okay, after adding, you can see the how to write in steps here. So MnO4 negative plus Fe2 positive plus H positive gives Mn2 positive plus Fe3 positive plus H2O. If you have to balance this equation, this unbalanced equation, with the help of ion electron method in acidic medium, so you can follow these steps. First of all, we will use half reaction method to balance the equation, separate the oxidation half. You can see this is the oxidation half reaction and this will be the reduction half reactions. Okay, you have to add single electron here, so that what, the charges becomes equal, and you have to add, you have to follow all the steps that we have already discussed. Okay, and then you will get this equation as a final equation. So MnO4 negative plus 8H positive plus 5 Fe2 positive gives Mn2 positive plus 4H2O plus 5 Fe3 positive. After balancing, when you will get your answer, so what you have to do, the final step will be, let's check the number of atoms and the total charge. So here I am writing element, then I will write reactants, then I will write product. Okay, so if I am writing element, reactants and products, so you can say Mn, manganese, oxygen, hydrogen and iron. Okay, these are the elements present in the reactant side and product side. You can say in the reactant side how many Mn, 1, how many manganese are present on the product side, you can see 1. Oxygen, you can see left hand side 4 oxygen and right hand side 4 oxygen. And hydrogen, you can see 8 hydrogen and 4 to the 8, so 8 hydrogens both side. Then you can see 5 Fe and 5 Fe. Okay, so the number of atoms of each and every element in the reactant side and product side are equal. But let's check for charge. If the charge is not equal, na, so definitely the equation will be not balanced. Okay, equation is not considered as balanced chemical equation. Okay, so you can see total charge. So 8 positive is here, 5 to the 10 positive is here, and single negative is here. So 10 plus 8, 18 or minus 1, 17 positive total in left hand side. Then you can see 2 positive and 5 3s are 15 positive. 15 plus 2, 17 positive total in the product side. That means the total charge 17 positive and 17 positive is on both sides, so the equation is balanced equation. Okay, number of atoms are balanced, charge is balanced, so equation is balanced. Let's go to the next part. The next part is going to be very simple. Step 10, check for balancing part. 5Fe2 positive plus MnO4 negative plus 8H positive plus 5Fe3 positive plus Mn2 positive and plus 4H2. This will be the final balanced chemical equation. Okay, so the number of atoms and the charges are balanced on both sides in this equation. You can see 5Fe, 5Fe. We have checked already. 1Mn, 1Mn, 8 hydrogen, 8 hydrogen, and 4 oxygen and 4 oxygens. And the charges are also equal on both sides. So let's move to the some important questions for JEE exams. Okay, that's going to be very interesting. So focus. So you can see here question number 1. The question number 1 is saying that in which of the following reaction H2O2 hydrogen peroxide act as a reducing agent? I already told to you some definitions of oxidation and reduction, right? 4 to 5 definitions. And if the species is undergoing oxidation, it can act as a reducing agent. So reducing agent means you have to find the species that is undergoing oxidation. If the species is undergoing reduction, that will be known as oxidizing agent, because oxidizing agents oxidize others and itself reduced, right? And reducing agents reduce others and oxidize itself. That's the point. So oxidation means you can say loss of electron. Okay, either electrons are written on the product side, or you can say a reactant side. If I am writing in case of oxidation, suppose I am writing Mg gives Mg2 positive plus a 2 electron like this, so Mg is undergoing oxidation here. But another type of representation, sometimes I can write Mg minus 2 electron gives Mg2 positive like this. Okay, so you can check on both sides. You can see plus 2 electron in the reactant side, addition of electron, no, it will be a gain of electron. Gain of electron means definitely reduction, and reduction means oxidizing agents, but we have to find reducing agents, so this is not the answer. Minus 2 electron, yes, minus 2 electrons definitely H2O2. You can see here oxygen atomic oxidation number will be -1 here, right? Will be -1 here, and here is 0, so -1 to 0, right? And similarly hydrogen is +1 here and it is +1. So what is happening here? -1 to 0, definitely the increase in oxidation number. Increase in oxidation number means oxidation, and oxidation means you can see here also loss of electron. Loss of electron, that means -2 electron. Okay, minus means from reactant side. Either you can write this -2 electron here in the product side like this, +2 electrons. Okay, so if this is undergoing, if H2O2 is undergoing oxidation, so it can act as a reducing agent. So second will be the answer. H2O2 plus 2 electron, no, again plus. Addition of electron means gain of electron, and gain of electron means, you know very well, gain of electron means reduction, and reduction means oxidizing agents, and gain of electron means reduction. Listen me very carefully. Okay, gain of electron. Okay, last one is, again you can see here is what? Removal of electron, removal of 2 electrons, so definitely it will be the answer. So 1 and 4. So let's see the solution here. You can see reducing agent is an element or compound that loses an electron to an electron recipient in a you can say redox chemical reaction. Okay, so in 2 and 4, H2O2 act as a reducing agent, so option 2 is the answer. Okay, in 2 and 4, you can see 2 and 4. Okay, so let's go to the question number 2. Very easy question. How many electrons are involved in the following redox reaction? The question is asking how many electrons are involved in the following redox reaction. This is an unbalanced chemical equation. The question is looking very simple, but that's not a simple question, right? Because you have to balance this equation first. So let's balance this equation with the help of ion electron methods. Okay, so the equation is here Cr2O7 2 negative plus Fe2 positive. So I am writing the equation here Cr2O7 2 negative plus Fe2 positive plus C2O4. You know C2O4 2 negative, C2O4 2 negative. What is that? C2O4 2 negative. It's oxalato ion. You know COO negative and COO negative. This is oxalate ion. Okay. Okay. Cr3 positive, Fe3 positive, and CO2. That's very simple. Cr3 positive, Fe3 positive, and CO2. You can follow all these steps. Okay, you have to assign oxidation number, so you can assign here 2x minus 14 equal to minus 2. You will get x value is minus 14, and then it comes out to be plus 14, then plus 12, then plus 6. Okay, then plus 6 is the oxidation number here. It is in the monoatomic form, so you can see plus 2. Again you can calculate for this, so 2x and minus 8 equal to minus 2. It comes out to be 2x is equal to plus 6, that means plus 3. Okay, plus 3 for carbon. Then you can say it is plus 3, then you can say it is plus 3, then you can say for this it will be plus 4. How? You can see x minus 4 equal to 0, so x will be plus 4. Okay, so plus 4. So what you can see here, what you can observe here, chromium plus 6 to plus 3, definitely it is reduction. So what will be the reduction of reaction? Cr2O7 2 negative to Cr3 positive. It is reduction of reaction. What will be the oxidation of reaction? Let's check. Okay, let's write this oxidation and reduction of reaction in two half. Okay, so that we can easily balance and then we can add these. Okay, you can use this method. That's a very simple and easy method. So what you can do, you can make a line here, then you can write oxidation half reaction here, and you can write reduction half reaction here. So what is the reduction of reaction? Cr2O7, it is reduced because of decrease in oxidation number. Decrease in oxidation number plus 6 to plus 3. Plus 6 to plus 3. Okay. Decrease in oxidation number means reduction, and that means it is acting as an oxidizing agent. That's very simple. Okay, you have to be very careful while assigning the oxidation number. Again and again I'm saying this point. Okay, so Cr2O7 2 negative gives Cr3 positive plus 6 to plus 3. Plus 6 to plus 3 means decrease in oxidation number. Decrease in oxidation number means reduction, and reduction means it will act as an oxidizing agent. Okay, so let's write oxidation of reaction. So Fe2 positive to Fe3 positive, that means Fe2 positive, and also plus 3 to plus 4. So in both cases increase in oxidation number, so you can write combined form Fe2 positive plus C2O4 2 negative gives Fe3 positive plus CO2. Okay, let's balance this. First of all, balance the atoms other than hydrogen and oxygen. So iron 1 here, 1. Okay, then balance carbon 2, then multiply with 2 here. Now the atoms other than hydrogen and oxygen are balanced, so let's balance the oxygen and hydrogen. So oxygen you can balance with the help of H2 molecule. So 4 oxygen and 2 to the 4 oxygen. So oxygens are also balanced. You can see 4 oxygen, so no need to add hydrogen. Now balance charge. Okay, so you can see total charge will be 2 positive, 2 negative, 0, and here 3 positive. Total 3 positive. Total 3 positive means you have to add 3 electrons here. You have to add 3 electrons here. Let's balance the now 3 positive, 3 negative will be 0. So the total charge will be balanced on both sides. Now let's balance the reduction of reaction. First of all, you can balance the atoms other than hydrogen and oxygen. So Cr2O7 2 negative, and you have, here you can write 2 Cr3 positive. Now you can see here oxygen, 7 oxygen, so you have to add how many water molecules? 7 water molecules. Now both sides 7 oxygen atoms are there. Now what you can do? You can do one thing, hydrogens, right? So 7 to the 14, so 14 hydrogens are there, so you can add 14H positive here. Okay, 14H positive here. So 14H positive means, now let's check the charge. So 14H positive and 2 negative, so total 12 positive is here, and 2 3 is 6 positive, so you have to add how much? 6 electrons here. You have to add 6 electrons here, because total 6 positive is here. So if you will add 6 electrons, so it comes 6 positive, because 12 minus 6, 6. Okay, yes. So now what you can do, now the equation is, I am writing the final equation of oxidation of reaction. It is Fe2 positive plus C2O4 2 negative gives Fe3 plus 2 CO2, right? And similarly you can write the reduction of reaction final equation. Cr2O7 2 negative plus 14 H positive. Okay, I have not written the electrons here, so you have to write 3 electrons as well. Okay, plus 14 H positive plus 6 electron, plus 6 electron gives 2 Cr3 plus 2 Cr3 plus 7 H2O. Now you can see 3 electrons and here are 6 electrons, so you can multiply the entire equation with 2 and you will get the balanced chemical equation. Okay, what you will get? You will get 2Fe2 positive, 2Fe2 positive plus 2C2O4 2 negative. Okay, then 2Fe3 positive, then 4CO2, then 6 electron. Then what you can do, you can add these both equation and you will get your answer. So let's see the solution of this particular question. You can see a redox reaction in any chemical reaction in which the oxidation number of a molecule, atom or ion changes by gaining or losing an electron. Chromium and iron are involved in this reaction, which is oxidized and reduced. My point is here, right? You can add these what I can say, you can add these equations, then you will get the final balanced redox reaction. But the point is here, how many electrons are used here? You can see 6 electrons. How many? 6 electrons. Okay, so 6 will be the answer. So let's see. You can see here chromium and iron are involved in the reaction, which is oxidized and reduced. So a total of 6 electrons are involved in this redox reaction. So option 4 is the right answer. Okay, so that's not an easy task, but you have to balance the equation first of all, then you can see that 6 electrons, okay, are involved here in this following redox reaction. Okay, in the following redox reaction. Okay, so let's go to the next. This is the answer of the question number 2. Question number 3. Which of the following reactions is an example of a redox reaction? Redox means, red means reduction and ox means oxidation. That means the reactions in which both oxidation and reductions are occurring simultaneously are known as redox reaction. So let's check the oxidation number. Okay, another method what you can check, you can see XeF4 to XeF6, so addition of more electronegative element, right? Addition of more electronegative element. And O2F2 to O2, that means removal of more electronegative element. XeF2 to XeF positive, right? You can check the oxidation number, but I am just checking with the simple terms, okay, that we have covered, we have discussed with the simple definition. XeF2 to XeF, that means removal of more electronegative element. PF5 to PF6, that means addition of more electronegative element. XeF6 to XeOF4, removal of more electronegative element. H2O2 to HF, addition of more electronegative element. XeF6 to XeOF2, removal of more electronegative element. H2O2 to HF, that means addition of more electronegative elements. Okay, so you can see here in equation 1, Xe undergoes oxidation and oxygen undergoes reduction. Okay, because we have to check redox reaction. So in the equation 1, you can see Xe, it is what, plus 4, and oxygen is what here? You can see in O2F2, fluorine is minus 1. So oxygen will be what? 2x and then minus 1. So you can calculate here, and Xe, what I can say, Xe plus 4 to Xe plus 6. So plus 4 to plus 6, oxidation, right? Plus 4 to plus 6, oxidation, and you can say oxygen undergoes reduction here. Oxygen undergoes reduction here. So oxidation and reduction both are occurring here. So definitely in equation 1, xenon undergoes oxidation and oxygen undergo reduction. So option 1 is the correct answer. Option 1 is the correct answer, not second, because you can see Xe plus 2 and you can see again Xe comes out to be plus 2. Okay, you can see Xe plus 6 and then you can calculate again Xe plus 6. You can say Xe plus 6, again you can calculate Xe comes out to be plus 6. So you can assume these things. Okay, so not second, third and fourth, only first is the correct answer. Question number 3, I hope this is clear. Let's move to the next question number 4. Which of the following is a redox reaction? Redox reaction, again you can do this question. NaCl plus KNO3 gives NaNO3 plus KCl, CaC2O4, right, calcium oxalate, and plus 2HCl gives CaCl2 plus H2CO4, H2CO4. Okay, MgOH whole twice plus 2NH4Cl, MgCl2 plus 2NH4OH, Zn plus 2AgCN gives 2Ag plus ZnCN whole twice, plus ZnCN whole twice. So you can see the answer. A redox reaction is any chemical reaction in which the oxidation number of a molecule, atom or ion changes by gaining or losing an electron. If oxidation number increases, definitely you can say it will be, if oxidation number increasing, it will be what? Oxidation. If oxidation number decreasing, it will be reduction. The oxidation state shows a change only in reaction between zinc and cyanide. Okay, if you will check all these, so you can see it will be 0, it will be +2, and it will be +1, it will be 0. So you can see 0 to +2 oxidation and +1 to 0 reduction. Okay, like this you can understand. So option 4 is the correct answer for the question number 4. Let's go to the question number 5. When KMnO4, okay, act as an oxidizing agents, okay, and ultimately forms MnO4 2 negative, MnO2, Mn2O3, and Mn+2. Very simple. The number of electrons transferred in each case. So KMnO4 is undergoing MnO4 2 negative, MnO4 2 negative. Then in the second case, KMnO4 undergoing MnO2. Third case, KMnO4 forming Mn2O3. Next, KMnO4, it is acting as an oxidizing agent. Na? Listen me very carefully. It is acting as an oxidizing agent, so definitely it will undergo reduction. Because oxidizing agents oxidize others and reduce itself, right? So decrease in oxidation number will take place. And in the next case, you can see KMnO4 to Mn+2. So you can see in KMnO4, manganese oxidation number will be, suppose this is X, or potassium will be +1, this is X, and this will be -8, and it is neutral, so 0, so X comes out to be +7. So in each case, can I write +7? Yes, I can write. So +7, +7, +7, and +7. In this case, it is very simple. It is in monoatomic ion form, so +2. In this case, you can calculate 2x and -6 is equal to 0. X comes out to be +3. Okay. In this case, you can see x is equal to -4. X -4 equal to 0. So x comes out to be +4. So +4 is here. And in this case, you can see x and -2, 4 ja 8 is equal to -2. Then x comes out to be +6. So here +6, here +4. So 7 to 6, 7 to 4, 7 to 3, 7 to 2, 6, 4, 3, 2, 6, 4, 3, 2. You can see, and the number of electron transferred in each case, not the oxidation number. Okay, number of electron transferred. So in the first case, +1 electron. In the second case, +3 electron. In the third case, +4 electrons, right? 7 + 4 electron gives +3. And in the next case, +5 electrons. So 1, 3, 4, 5, 1, 3, 4, 5, 1, 3, 4, 5. The oxidation number of manganese in KMnO4, MnO4 2 negative, MnO2, and Mn2O3 is what? 7, 6, 4, 3. I already told to you, 7, 6, 4, 3. In KMnO4, it is +7. In MnO4 2 negative, it is +6, and in MnO2 it is +4, in Mn2O3 it is +3, and in MnO2 it is +4, in MnO4 2 negative it is 6, in KMnO4 it is 7, and in last one Mn2 positive it is 2. Okay, in Mn2 positive it is 2. Okay, the number of electron transfer corresponds to the change in the oxidation number when KMnO4 act as an oxidizing agents and ultimately forms MnO4 2 negative, MnO2, Mn2O3, and Mn+2. Then the number of electron transferred according to this particular change in oxidation number, you can say will be 1, 3, 4, 5. So correct option will be 3. Correct option will be 3, and you already know the answer we have discussed. Okay, the next is question number 5. Question number 6. The oxidation state of chromium in the final product formed by the reaction between Ki and acidified potassium dichromate solution is. So you can see the reaction. Okay, you can see the reaction: potassium dichromate K2Cr2O7 plus 7H2SO4 plus 6I Ki potassium iodide. Okay, you can see K2Cr2O7 is what? Potassium dichromate, right? And it will give Cr2O7 Cr2SO4 plus 3I2 plus 7H2O plus what? K2SO4, Cr2SO4 whole thrice. Okay, you will get Cr2SO4 whole thrice here. If you want to balance the, suppose let's take oxygen. So you can see 7 oxygen here. You can take 28 oxygen here. So total 35 oxygen. Let's check here. 4 3 ja 12 oxygen plus 7 oxygen, and 4 4 ja 16. 16 plus 7, how much? 23 plus 12, 35. So you can see 35, 35. So the number of atoms of each and every elements are balanced here. So you can see here, you can calculate the oxidation number for chromium in case of K2Cr2O7. You know very well, you have to assume chromium X oxidation number. It will be 2 plus 2x minus 14 is equal to 0. X comes out to be plus 6. You can write plus 6 here. Then you can calculate for this Cr2SO4 whole thrice. Cr2SO4 whole thrice. We know very well SO4 is completely minus 2, right? So 2x and minus 2 3 ja minus 6 is equal to 0. X comes out to be plus 3. X comes out to be plus 3. So it is undergoing a change, plus 6 to plus 3, plus 6 to plus 3, plus 6 to plus 3 means 3 electrons are what added here. 3 electrons are added here because it is acting as an what type of agent? Oxidizing agent. It is acting as a oxidizing agent. So the oxidation state of chromium in the final product will be plus 3. In the final product will be plus 3. So option 4 is the correct answer. Okay. What I want to say, if the chromium is changing from plus 6 to plus 3, so definitely what is happening here? Addition of 3 electrons, right? Plus 6 to plus 3. So the gain of electron is here. That means it is undergoing a reduction. So it is acting as an oxidizing agent. It is acting as an oxidizing agent. If it is acting as an oxidizing agent, so you can say oxidizing agents are those agents which can reduce itself and oxidize others. So oxidizing agents are those agents which can oxidize others and reduce itself. So Cr plus 6 is undergoing reduction here. Cr plus 6 plus 3 electron gives Cr3 plus. Okay. So question number 7 is this. In chromyl chloride, the oxidation state of chromium is very simple. You can see the correct answer is 6. In chromyl chloride, the formula is CrO2Cl2. The oxidation state of chromium can be calculated by what? In chromyl chloride, the oxidation state of chromium can be calculated by assigning oxidation states to the other atoms in the molecule, and then using the fact that the sum of oxidation state in a molecule must be equal to 0. The oxidation state of oxygen is usually -2 and the oxidation state of chloride is usually -1. So you can see here Cr, you have to check what chromyl chloride oxidation state. So CrO2 Cl2, you can assume X, you can see it comes out to be -4 and -2 is equal to 0. X value is plus 6. So the oxidation state of chromium in chromyl chloride is plus 6. This is the question 7. Let's go to the next question. Next question is 8. Okay, see the following chemical reaction. You can see Cr2O7 2 negative plus XH positive plus 6Fe2 positive gives YCr3 positive plus 6Fe3 positive plus ZH2. Very simple. You have to balance this equation. You can see the correct answer comes out to be what? 23. To find the sum of X plus Y plus Z, we need to balance the given chemical equation. So Cr2O7 2 negative plus XH positive plus 6Fe2 positive gives YCr3 positive plus 6Fe3 positive plus ZH2. Let's balance the reaction step by step. Balance the chromium atoms first of all. You can see there are 2 chromium atoms on the left side of the equation. So we need 2 chromium atoms on the right side. Thus Y will be 2. You can see Cr2 and 2 Cr. Now the chromium is balanced. So Y value is what? 2. Balance the oxygen atoms. There are 7. You can use the oxidation number method. You can use the half reaction methods. Okay. So you can use any of the method. If in the question it is written particularly you have to use that particular method, so you have to use that particular method. But for JEE exams you can use you can use any method because of what? Because here in question you will get only options. Okay, you need not to solve, you need not to give the solved answer. Okay, you have to just tick the answer. So there are 7 oxygen atoms on the left side of the equation. So we need 7 oxygen atoms on the right hand side. Since each water molecules contains only 1 oxygen atom, so you have to put 7 here. So Z value comes out to be 7. Third step, balance the hydrogen atoms and charges. So there are 14 hydrogen atoms on the right hand side. So you have to put 14 hydrogen atoms on the left hand side. So definitely 14 H positive. So X value comes out to be 14. So 14 plus 7. What? 21 plus 2, 23. So this is the balanced chemical equation. Cr2O7 2 negative plus 14H positive plus 6Fe2 positive gives 2 Cr3 positive plus 6Fe3 positive plus 7H2. This is the balanced redox reaction and the answer will be what? Answer will be 23. Okay, answer will be 23. Let's go to the question number 9. Which of the given reaction is not an example of disproportionation reaction? 2H2O2 gives 2H2O plus O2. So you can try this question. Okay, 2NO2 plus H2O gives HNO3 plus HNO2. MnO4 negative plus 4H positive gives plus 3 electron gives MnO2 plus 2H2O. Disproportionation means self oxidation, self reduction. Only you have to use this concept: self oxidation and self reduction. Self oxidation and self reduction. 3MnO4 2 negative plus 4H positive gives 2MnO4 negative plus MnO2 plus 2H2O. So you have to check the species. If the species itself undergoing oxidation and reduction both simultaneously, you can say that is known as disproportionation reaction. Now question number 10. So you have to what you have to try these questions as an homework, question number 9 or question number 10. So the dark purple color of KMnO4 disappears in the titration with oxalic acid. Oxalic acid formula is what? Oxalate ion, right? COO negative or COO negative. So if I want to write oxalic acid, so let's put H here. So this is the formula of oxalic acid. Okay, the overall change in the oxidation number of manganese in the reaction. So the dark purple color, you have to write the reaction between KMnO4 and oxalic acid, then you will get some products. Then you have to check what will be the change, what will be the overall change in the oxidation number of manganese in the reaction. Okay, in the reactant side I can tell, and you have to check products, then you will check the oxidation number of manganese in that particular product. Okay, so for this you can assume X, and for potassium it is +1, so -2 4 ja 8, and it is neutral, so 0. So X value is +7 here. X value is +7 here. So that means the oxidation number of manganese in KMnO4 is +7. So that's interesting, definitely interesting. Now you have to check the overall change. Okay, it's not +7, so that should not be the answer. That's very simple. Okay, so it can be +7 if it comes out to be 0. Okay, it can be +7 if it comes out to be 0. So then, so this is all about this class. Thank you so much everyone.